So today we will be bringing you through a little journey, which is a journey of the life of a coffee bean from tree to cup. And I will start the presentation first. So before we dive into all the exciting things about how flavors and aromas are formed or what actually happens during roasting and extraction, I would like to ask a very simple question to all of you coffee lovers. What actually is a coffee and where does it come from? So coffee actually doesn't just begin in a cafe. Actually it begins in the cherry of a coffee plant under the genus Coffea. This is the plant. Okay. So inside the cherry, there's seeds, and this seed, which is the green coffee bean, is what makes into a coffee drink. Okay. So the plant is first discovered in Africa and deep within the humid tropical forest, and then eventually it started spreading worldwide and now evolved into what we know globally as coffee. Next. Okay, so since now we know what coffee is, I have another question for you. Whenever you go to a different shop or even in the same shop, have you ever wondered why does the coffee taste slightly different? Okay, so actually there's a scientific reason behind it, and now I will be briefing you through why and how. Okay. So one important thing that I want you all to know before I start is that the flavor of coffee and quality is actually affected by the chemical composition of the bean. And what shapes the chemical composition of the bean? Well, it's actually a few factors. Okay, for the first one is environmental factor, following genetics, post-harvesting processing, roasting, and extraction. So for my part, I will be talking about two major factors, which is genetic, the type of coffee bean, and also the environmental factor, which includes altitude, climate, and soil composition. Just a note, the environmental factor here meaning is the environment where the coffee tree develops its cherry. That's the environment. So did you know that actually there's more than 125 species of coffee, but eventually there's only a few are consumables, and 3 of it is Arabica, Robusta, and Liberica. Okay, so as I mentioned before, genetic is one of the reasons why they have different flavors. It's okay, so now imagine this. Arabica, Robusta, and Liberica, they're all different people. So Arabica is like the gentle one, and it has a smooth, complex flavor, distinct like of bitterness. Then for Robusta, it's like the strong, bold one, the tough one. Okay, it often has a very strong smell and somewhat a flat, almost burnt taste, which is usually because it has a higher caffeine content, around 2 to 2.7%. Last but not least is Liberica. We can also call it the Malaysian underdog, okay, because it is planted in Malaysia, Johor, where we can find it, but it's not really internationally sold, commercialized, and it's also because it's very unique. It has a cool floral aroma with bold smoky flavor. Okay, so now let's zoom into the types of Arabica coffee. So over hundreds of years, as the coffee is spreaded throughout the globe, there's definitely some mutation, natural selection, even intentional selection, selective breeding. So all of this actually starts to change its genetics. So by changing it, then we have different varieties as shown here. There's actually more, but these are some examples. And this different genetic makeup actually causes it to have a different flavor profile. So here, for instance, a very classic example of Arabica. It has a very sweet and clean with low acidity and medium body. But whereas for Bourbon, another classic example, is usually often described with a complex and higher acidity taste. And the longer list goes down, but the main takeaway point is that genetic actually affects the taste of coffee. Well, just some simple explanation is because that the genetic actually affects how much and what type of flavor precursors are produced inside the bean. Example is caffeine, sugars. Yeah. So basically that is how genetic shapes it. But have you? There's another interesting point is that even though it's the same varietal, which is exactly the same genetic, but then when it's grown in different places, it actually gives you a different taste. Okay, so this is because the taste is also affected by environmental factors. So the first environment, why I say that I'll let you relate like okay. So it's just like durian from Johor may taste different with durian from Pahang. So the same goes with coffee, which is the flavor is heavily influenced by environmental factors, and there's three main categories. The first is altitude, second is climate, and third is the soil composition. So firstly is the altitude. So whenever the coffee is grown at high altitudes, eventually it will have slower growth because of the lower temperature at high altitudes. Just like when you go to the mountain, it's colder, right? Yeah. Similar like that. So whenever the cherry grows slower, eventually it has more time to develop its flavors, which includes the acidity, the sweetness, and also the overall flavor. But here's a twist. Higher altitude doesn't always mean that the coffee flavor is very good or means that it's a better quality. It really depends, but most of the time it is. So why is it not always like this? It's because that different varietals will have different reactions. Some varietals may not be affected by altitude, meaning that no matter which altitude you plant it, still gives you the same, but some might even give you a worsened quality. So it's really dependent. And another side note is that at extreme altitudes, for almost all the types of coffee bean, it actually stresses the plant, which when the plant is stressed, you get undesirable flavor coffee beans. So next, I'll be talking about climate. So coffee trees are actually very sensitive, which especially towards the rainfall, humidity, and temperature. So for humidity and rainfall, whenever there's insufficient rain, it actually stresses the tree, not enough water, etc. So it leads to small haze eventually. And when there's excessive rain, okay, especially during the harvesting time, it will actually promote over-fermentation and also some mold formation, which is also bad for the tree. Whereas for temperature, whenever the higher temperature, but not too high, ideal temperature will eventually promote flavor development because like what I mentioned earlier, slower growth and more time to accumulate all the nice flavors of the coffee bean. And at warmer temperature, it's very rapid. Okay, so let's complex flavors, same concept. So just an example, for Arabica, it usually grows best ideally at 50 to 24 degrees Celsius, which is slightly lower temperature. Okay? And also it grows best at high humidity and also with places with steady rainfall at about 1,500 to 2,000 liters per second. So now last but not least, I'll be talking about the soil composition. So about how it actually affects. So soil is actually not just dirty, like soil, yeah, but it's actually like a pantry for the coffee bean. Okay? So it actually provides the nutrient and also it determines how well the coffee plant can absorb the nutrients. So generally, coffee trees will grow well in acidic soil, which is around 4 to 5, okay, lightly acidic, not too acidic, and then also with good water retention, and also a soil with very rich nutrients because they need nutrients to grow their plant, their cherry, which you get the coffee beans. interesting note is that different soils will eventually give you a different flavor profile as well. Okay, here's an example. So whenever we use volcanic soil, usually the coffee will have a vibrant, fruity, and full body flavor. Whereas for red soil, which is iron rich, usually you get a more chocolatey and caramel taste in the coffee. Okay. So before I wrap up my part, I would like to clarify some misconceptions. The first is that only bean type determines the flavor, which is a big no. It's because I know genetic effects, but as I mentioned also, the environmental and the post-harvesting processing methods all actually affect the flavor of coffee bean. Okay, the next misconception may be, oh, this coffee bean is from the same place, so it must definitely taste the same. It will have the same quality. Another no. Like I mentioned earlier, even if it's the same variable, you plant it even 10 kilometers apart, you might get a very different flavor because of the altitude, climate, okay, and the soil composition. Most importantly, the soil composition. Oh, another interesting side note is the soil microbiome. Okay, although more study needed to clarify this point, but it might be one of the factors. So, in short, the flavor of coffee doesn't just start in the cafe, but starts from the tree. Okay, so factors which is genetics, the type, species, varietals, the altitude, the climate, and also the soil composition will eventually affect the chemical composition of the bean, which will then affect the final flavor of the coffee. So thank you, and now I'll pass the stage to the next presenter. We've learned about some general information about coffee bean. So now I would like to ask a quick question. And when you drink coffee, do you ever think about like how the coffee travels from a fruit, from a tree, to the bean in our cup? And now I'm going to explore that journey here. So before talking about the processing method, let us understand the anatomy of the coffee cherry. So coffee cherry is the fruit of the coffee tree, and then it has several layers. Outside you have the skin and pulp, and then we have the sticky, sugary layer called mucilage, and then inside will be the bean that we all know. So coffee processing is a series of steps that remove the skin, pulp, and mucilage, so that the bean inside will become a stable green bean for roasting. And this is like peeling a fruit layer by layer until we get to the seed inside. And coffee processing is actually a very important step because it shapes the final flavor of the coffee, influencing the sweetness, acidity, and body of the coffee. And the first method is the natural process. It is the oldest and most direct method, where the coffee cherries are spread out in a thin layer and dried under the sun. So you can imagine like drying the grapes into resins. And so to avoid mold or rotting, the turning of the coffee cherry, known as racking, should be done regularly. And then after drying properly, the outer husk of the skin and dried fruit are removed. So the coffee with this processing method will have a fruity flavor like hints of strawberry, blueberry, or tropical fruit. So you may wonder why. This is because this process actually takes a long time, that may take several weeks, and during this process, the microorganisms like yeast bacteria will break down the sugar, producing compounds like esters and acids. So now imagine the bean is like a sponge. It is porous, so the beans will absorb the compound, the acid and esters just now, and therefore producing the fruity flavor. So we can taste lower acidity, fruity, or wine-like taste of coffee. And the second method is wash method. So unlike the first method where the beans, the outer skin of the beans are removed first. So the outer skin are removed after drying. And this one actually starts with depulping, which is the removal of the skin. And the pulp beans are now left with the mucilage layer and then are fermented in water tanks. So after fermentation, the beans are washed and dried. And the coffee using this method actually give a cleaner and brighter taste. And this is because the water and microbial activity in this process during the fermentation, it will break down the mucilage layer, making it easier to be washed off. So now once this layer is removed, so the bean can no longer absorb the fruity flavor from outside. This is why the bean's flavor will mainly develop from the bean itself. This is why we can taste brighter, cleaner, lighter body taste of coffee with floral, citrus, and tea-like notes. And the third one is honey process. So this process is like a mixture of the previous two. So like the wash process, the coffee cherries are depulped, and then like the natural process, the beans are dried without washing off the mucilage layer. So the coffee with this processing method will have a brown sugar taste, and this is because the sugar in the mucilage layer provide food source for the microbe, but it's actually less than the natural one. So the fermentation is actually less intense, and as the bean dry, the sugar on the surface caramelizes, giving sweetness. And now you can imagine like making a caramelized roast chicken. So there is sugar on the surface. The heat causes caramelization, and outside will be sweet and flavorful. So this is why we have a stone fruit brown sugar taste of coffee, just like the name of this process, honey. And now there are some emerging methods of coffee processing that can improve the sensory quality of coffee cherry. For example, we have anaerobic fermentation, where the coffee cherries are fermented in an oxygen-deprived condition in a bioreactor. So inside the bioreactor, we may or may not have starter culture like yeast, mesophilic bacteria, and lactic acid bacteria. So what is a starter culture? So it is a group of microbes added to foods in order for us to take advantages of the product derived from their metabolism. And this method improves the sensory quality of coffee cherry by removing the woody notes while adding the floral, fruity, and citrus notes. And then we also have carbonic maceration, where the coffee cherries are fermented in a rich carbon dioxide environment. So in the bioreactor, the air is removed and then carbon dioxide is injected into the bioreactor. And this is done as a preparative steps prior to the natural wash and honey processes. This method also improves the sensory quality of coffee cherry by adding the floral, fruity, and citric attributes to the coffee. And this is all for the tree to fruit, and then the journey will continue. That's all.
Alright, so let's continue our journey through the life of coffee beans. So before I start, I would like to ask you all a quick question. Have you guys smelled a gold green coffee bean before? If you haven't, they actually don't smell like coffee at all. They smell greasy and almost like grass or raw peanuts. So how do we turn something like this smell grass into something like your favorite cafe? The magic is actually happens during the roasting. Yeah, so when we roast a coffee, the bean will lose moisture, expand, release gases, and also develop hundreds of flavors and aroma compounds. This is the steps that truly unlock the coffee's flavor potential. Okay, now there are three major reactions that involve in the coffee roasting that create the flavor of roasted coffee. The first one is Maillard reactions. So what is Maillard reaction actually? Well, imagine that you smell the toasted bread or a grilled meat. That aroma, that smell, that instantly makes you hungry. Yeah, that is the result of Maillard reaction. So, in coffee, the Maillard reaction starts around 150 degrees Celsius when the amino acids and sugar inside the beans, they react and form a compound called melanoidins. Yeah, then this melanoidin is responsible for the coffee's brown color and its toasty or nutty flavors. So the second one is the caramelization. You all know, right, what is caramel? It's like you heated the sugar in a pan, and the moment it turns into golden and smells sweet and have a richer bean flavor. Yeah, something very similar happened in coffee beans, around 170 degrees Celsius. The natural sugar inside the beans, right, it will break down to form a caramel-like sweet taste, like also fruity or nutty notes. Like if you keep on heating it, so it might give some bitterness. And finally, it's the acid changes. Actually, inside the beans, right, it has many acids. For example, the fruity acids like citric acids. And the light roast will keep those fruity acids. While the dark roast might break down those fruity acids into a more bitter acid, which is, for example, quinine acid. So that's why the light roast will have a bright and fruity taste. However, the dark roast, it tastes like a bold and also bitter. And now, here is something that usually people does not expect. During roasting, right, like just now I said, coffee beans can expand their size up to double of its size. But they actually lost 12 to 24% of their weight, mainly because of the water and gases released. And they become more porous and brittle. Okay, so and then comes one of my favorite moments in roasting, which is the first crack. It sounds like a popcorn popping. This is because the bean bursts through the structure, and this signal the roast has entered a light stage. Yeah, if the roasting continue, right, there's a second crack. Yeah, which sound sharper and more intense. This happens when the internal cell wall fracturing and the oils move towards to the surface. as this changes begins, the color of the beans also change. Like for original one, the green one, like the previous picture that we show, from a green one to yellow one, and then to light brown, medium brown, and also the dark brown. So all of these color changes actually correspond to the chemical reaction that inside the bean that I presented just now. Like for example, the Maillard reaction and also the caramelization. Yeah, these all changes will help the roaster judge the roast level visually. And also during the roasting, right, the thin outer skin of the coffee bean called chaff and will dries up and also the flex off. This also is another visual sign of structural breakdown of the beans. So the different roast level actually will create different flavor profiles. Do you guys think that which roast level will have more caffeine level? You guys guess? Like yeah, correct. Actually, the answer is light roast because actually the caffeine, right, is heat stable, so it can last longer. It can stay inside the coffee bean even you roasting for a longer time. But the dark one will have less because of losing of the weight, the mass. Because just now I said, right, during the roasting they will expand but lost weight. Yeah. So okay, for the roasting level, the light roast will have floral or fruity notes with high acidity, and it is great for the pour over. For the medium roast, it has a balance and versatile, which for almost all type of brewing methods. So the last one is the dark roast, which it gives a smoky, bittersweet and bold taste, which is best for the espresso, French press, and mocha pot. So now, did you guys know that actually how the professional tells that the exact roast level to people? They're actually using a scale called Electron scale. This is a numeric color scale for roasted coffee. They use spectrophotometer. By the way, spectrophotometer is a machine that you put in the sample and then you pass the light through the sample. Then the machine will measure how many light that absorb and reflect. Yeah. So there are two main scales, with including the gourmet for light focus and also the commercial for dark focus. So actually for the result, right, the higher numbers, the higher actual numbers indicate a lighter roast, while the lower actual number indicates a darker roast. It's like inversely proportional to each other. For example, 85 to 95 indicates a very light roast. 55 to 65 is a medium roast, and the 35 to 45 is dark roast or French roast. So it basically helps us to keep every roast level consistent and ensure the batches test the set, and shows how the color of the beans that relates to how the flavor develops. So here are some several factors that will influence the roasting. The first one is the green its characteristic. For example, like its density, moisture, size, and also the processing methods. So, for example, dense, high altitude beans will need more energy to roast. And then the second one is the roasting environment and also the equipment. For example, the heat types, airflow, humidity, also even the room temperature can affect the roast. So, for example, like just like I said, right, during roasting, it will lose the moisture. So if you have high humidity, so you need more time to evaporate those water. Yeah. So the last one is the roast profile, which roaster recipe. So the charge temperature, rate of rise, and total roast height all can change the final flavors. Yeah. So let me ask, have you guys tested a coffee that like grassy or sour? That usually means an undeveloped roast. And if it tastes like burnt or hollow, that's overdeveloped. So here are some types of roasting methods. So the first one is the drum roaster, which is the classic one. It uses the traditional rotating drums. That beans are rotated inside a heated drum. It gives rich and classic flavors. Just think like because we want to rotate the beans in order to make sure all the beans like heated evenly. So the second one is the fruit bed roaster, which it roasts bean using hot air, and it gives cleaner and brighter flavors. Usually, this type of method is faster lah. Then the last one is the recirculation roaster, which it reuse the exhaust air to it is more energy efficient and consistent, which is great for the large batches. So if you think it visually, this drum roaster, right, is like you just baking your cookies, and then the flip bed roaster is like you blowing the hot air. Yeah, they both work, and they just create only slightly different flavor results. Yeah, alright, I think that's the wrap of roasting part. Let's keep our journey, continue going, and dive to the next chapter, which is coffee extraction.
Okay, now I will continue with the part where the coffee converted from beans to the liquid in your cup of coffee. So, behind every cup of coffee there lies a complex science which is called extraction. Extractions is referred to the process of dissolving dissolvable compounds such as acids, sugar, caffeine, and some aromatic compound from the coffee ground during brewing. And these soluble compounds, they are extracted in a sequence. So the firstly, acids and oils are extracted. For acids, they are relatively simple in chemical composition, so they dissolve in water easily. And as for oils, they are hydrophobic, means that they are afraid of water, so they will be washed out from the ground during the brewing. And at the same time, some aromatics, light aromatics compound will be dissolved, which provides notes like floral and fruity notes. And next, sugar will start to break down. Although simple sugars, they are more chemically complex than acids, so they need more energy and time to be dissolved. And lastly, the plant fibers that makes up the coffee ground will start to degrade and give a very bitter and harsh taste. So, in extraction, there are many factors that will affect them. But for today, I would like to focus on these 5, which is the grind size, the water temperature, minerals, contact time, and agitation. So we start with grind size. To start a brew, we need to grind our coffee ground into smaller particles. And grind size is a powerful tool to control the extraction. A finer grind, which will give a larger surface area that exposed to water. And when the surface area increases, the compound will dissolve quickly and efficiently and will give a higher extraction. So you will taste strong and intense flavor in your cup. Whereas for a coarser grind, there are less surface area that will contact with the water. So this compound they will extract slowly and giving a lower extraction with a lighter taste. As you can see here, these 2 pictures that shows that how big the difference of this grind size can be. This one is fine like powder. As for that one, it's just something similar to your sugar. So you guys might be curious about how we determine the grind size. In this figure here, it shows an electric grinder. So how we need to adjust the grind size with this thing. You can see here. Here, there's a number scale at the outer side of this knob. So the numbers indicating that the grind size, the lower the number, actually will give a finer grind. So this is for electric grinder. What if a manual grinder, a hand grinder? So this is a hand grinder. You see there's no number you can find outside this run. So where is the adjusting done? So look at this, this part. We have this thing. You can turn this thing and you listen to the clicks. Can you listen to the clicks?
Yes.
So each click means that you have adjusted the grind size. So there will be an indicator here to showing that which position you are turning, you will get finer or coarser grind size. The next factor is water temperature. And water temperature detects the energy availability of dissolving compound, and the temperature determines the kinetic energy of a water molecule. When a water molecule has, when the temperature increases, so the water molecule will have higher energy, so it will move faster and collide with each other more frequently and generate with greater force. So this collision will generally break the compound in the coffee ground, and this then easy to pull up from the coffee ground. At 90 to 96 degrees Celsius, the water reaches a kinetic energy sweet spot. So the water is hot enough to dissolve many of the flavor compounds from the coffee ground. As when the water is too cold, they have not enough kinetic energy. So this will give only acids are extracted, since they are the first one to be extracted and they are extracted easily. So it will give very sour taste. Next, moving on to minerals. Coffee is made up of 90 to 95% of water. In water, you will have a naturally occurring minerals, which these minerals will interact with the coffee grounds in dissolving the compounds. And these 3, magnesium, calcium, and bicarbonate ions, they are major contributor for these extractions. Magnesium and calcium, they are positively charged ion, so they will bind with the negatively charged compounds and then pull them out. So for example, magnesium will bind to acids and they will pull out the acid from the coffee coffee ground, enhancing fruity breath notes. As for calcium ion, it binds to a heavier compound, which will add to the body and creaminess of your cup. Whereas bicarbonate ion act as a buffer, it neutralizes the acid so that it will reduce some acidity in your cup and giving a smooth flavor and improved balance. Now, contact time is the duration when the water is in contact with coffee, and extraction is a time-dependent process where water needs time to break down the soluble compound and then extract it from the coffee ground. So when the contact time is too short, it will dissolve less desirable compound, so leading to a sour and thin cup where the acids are only extracted. As when the contact time is too long, the water starts to break down the fibers of the coffee ground and will extract some bitterness and astringent cup. And for different brewing methods, we have different contact time. For example, espresso, they have a very short contact time, but it lies around 25 to 30 seconds. Whereas for pour over, the contact times are usually between 2 to 3 minutes. And for immersion methods such as French press, so it usually has a very long contact time. It can be up to 4 minutes or longer. And lastly, we're moving to agitation. Agitation refers to the gravitational disturbance of the coffee ground by the water. So when you pour water, the water will start to dissolve will start to interact with the coffee particles. And some of the examples of agitations are stirring the brewers, and also turbulence from water during pouring. This agitation is very important as it will break up the dry clump. So when the dry clump is the coffee particles that stick together, and the middle part of the clump won't contact with water. So to prevent this thing to happen, we need to agitate it. And also, agitation will ensure that every ground is fully saturated and prevent under extraction. So this is a scenario when you are pouring the water direct, just in one point without moving it. So when the water sits still, so you pour it in the middle, and then the water that closest to the coffee ground and the middle part will be saturated with water and extract this compound. But for the coffee ground that surrounds the middle part will not get extracted because the water will not move to that part. Okay. So we have just talked about how individual factors will affect the extraction. So now we will look into how this brew method they put every factor into play. So for example, this one espresso. They use a very precise temperature, which is around 92 to 94 degrees Celsius. And the grind size they usually very bright, it's like powder. And then agitations will happen inside this thing. It's called a portafilter. So it's due to the high pressure. And the contact time is extremely slow, 25 to 30 seconds, due to the facility of the pressure. And for pour over, so the water temperature usually used is 90 to 96 degrees Celsius, and the grind size are medium fine to medium, which is similar something to a table salt. And agitation is when you are pouring, you swirl your brewer, or either you stir it. And the contact time, which is about 2 to 3 minutes, refers to the time needed for the water to drain off the brew. And lastly, this is a very different brewing method, which we use cold water as to extract this compound. So the grind size for this one is very coarse because we need to stop the bitterness from coming out. And the agitation does not play much for this one because it has a very long contact time. So you may do some agitation during the start and after you're done with your brew. So just to homogenize everything. And So, in summary, the many factors that will affect the coffee, from land to trees, from picked cherries to processing methods, from raw beans to roasted beans, and lastly, extraction that will give the coffee in your cup. Thank you.
Okay, so now let's move on to our Q&A sections. Do you guys have any question to ask?
Okay, so I want to ask, I'm curious about how do other factors such as roasting and processes affect the extraction?
I will answer your question. So, we talked about roasting just now. We have 3 different roast levels, which are the light, medium, and dark roast. So, during these 3 roast levels, they will have difference in density, which means there are different pores inside the coffee bean. So, higher density means that have a low pore, and a low density will means that you will have more pore. So when you pour your water to this coffee beans, the water will enter these pores and give a high extraction. And in contrast, when this bean has less pore, when you pour water into the coffee bean, and less water will enter these pores, will give you a low extraction. So this is the difference between roasting level. And for processing method, just now we have mentioned that natural and wash process, right? So these 2 are the traditional method. So in natural process, the beans are undergo fermentation, so that the gas are produced from the microbes will enter the beans and give pores, which will lead to the expansion of the beans. As for wash process, there are no fermentation, so the pore will be less, and this will give a higher density of the beans. Yeah, answer your question.
Yes.
I have a question to ask. Okay, so throughout the presentation, I heard the word body being used several times. Now, what does it actually mean when you say the body of coffee?
So that's from the processing method, I suppose. As I mentioned, like the body. So actually, the body means the texture the coffee feels in our mouth. So you can imagine when you drink milk, water, and tea. So for milk, after we drink it, we feel heavier. And then as for water, we actually taste, it has a cleaner taste. So that's the body means. And usually we hear full body, medium body, or light body. So for the light one, it's like water. It tastes cleaner. So I hope I answer your question.
Thank you.
So as what I know that there are many types of coffee beans. So does where the beans come from change how you should roast it?
I think I can answer you. Yes, because different type of beans actually have different characteristics, right? Like density, moisture, all of them. Yeah. So we need, in order to extract, in order to take the best level of each coffee beans, we need to adjust the roaster profile.
I have another question. I was just outside just now and it's very hot. So it got me thinking, if climate change happens, right, does it affect the flavor of coffee and does it mess with coffee farms and how does it happen?
So I'd like to answer this question. So yes, eventually climate change will affect how the coffee flavors, and also it will actually make coffee farms threatened because, as mentioned earlier, that climate is actually one of the major factors that shapes the flavor of coffee. So when there's climate change, the temperature, humidity, the rainfall all changes, and eventually, usually, climate change will lead to a more undesirable flavor. Because you get hotter, and as mentioned before, coffee prefer lower temperatures. So yeah, yes, it will definitely mess with coffee farms as
well. I would like to know that can we actually mix the different processing method?
Okay, so that's for my part. Yes, actually. And in fact, coffee folks actually love experimenting to look for new flavors of coffee. So we can actually do
So excuse my wife, she's a bit shy, but she has a question as well, as in, after you roast coffee beans, like what should you do afterwards?
I think it's for my part, roasting, right? If after you roast the beans, right, you need to like quickly cool it down, because like just now I said, if you keep applying heat, then the like you're cooking your food, it will burn, and we don't want that taste too bitter or burnt taste. I hope I answered your questions.
My wife says thank you.
Any question else?
As I know, in Malaysia, Johor is the only place that I know provide the coffee, the processed coffee in Malaysia. So, what are some coffees only found in tiny places?
I think I'll answer this question. So majorly it's because that every place has its unique weather and soil composition. So meaning that at every area, even if it's just 10 km apart, if you plant the coffee beans, you eventually get a different flavor of coffee bean. And this is why, like in Johor, the coffee bean taste can only be found in Johor because of its unique weather and its unique soil composition, which gives the very unique flavor of coffee. Hope that answers your question.
Oh, now I understand.
This is a question from the back. How exactly do you measure extraction?
Okay, so this is a very good question. So to measure extractions, we have an equipment which is called the refractometer. It's a small box. So what you do, we take a few drops of the coffee liquid that you have extracted and drop it onto this refractometer. And leave it for a few seconds, then you will get a number which is called TDS, the total dissolved solid. So you need to calculate, you want to find extraction, right? So you will use this TDS to times the overall liquid that you have used in your brewing and divide by the dry coffee that you use. So you will get a percentage of number of extraction.
As I know, there are many types of flavor of coffee, many brands like Nescafe, Nestle, etc. So, are some roasts healthier than others? What the difference between the different roasts?
Actually, like the roast, I think your question is, does different roast level will affect the like more healthy or
Yes.
right? So actually, they are not really like one are healthier than others, but for light roast, it have more antioxidants. For dark roast, will lose some lah, but actually not really affect the healthy. I hope I answered your questions.
Yes.
Okay.
I have another question. So this morning, as I was going to work, I made a cup of coffee. then my son drank that coffee and said it was sour. So I always wondered, it never tasted sour to me, so I wondered, does sour coffee mean it's bad?
Okay, so actually sour doesn't necessarily mean it's bad. So if the sour is pleasant, like it's bright or fruity, like citrus taste, it's actually good. It actually indicates that the bean is grown in a higher altitude area where lower temperature, slower grows, then more complex aroma, more acidity, more sweetness. So, but if the sourness that you tasted was very sharp and unpleasant, it's most probably due to the technique area, which is under extraction. So it really depends on what kind of sour you tasted. Hope that answers the question.
Okay, actually, what is a charge temperature you say just now?
Oh, I think it's for my part, right? During the vectors part. Yeah, the charge temperature actually is like just the initial temperature of the drum, the roaster. Yeah. So it's when you introduce the green bean into that machine. What is the temperature? That is the charge temperature, the initial temperature.
So means that you cannot just quickly pour the beans right after you on the machine?
Yes, you need to set up first the initial temperature. If not, it will affect the roast.
Okay.
Yeah. Any question else? If no, that will be end of our presentation today. Thank you.
Belum minit.
我们有音乐可以放。